All right, so there was this question where you're given a distribution in binomial and a distribution in Poisson, and you're asked to find out the probability that 2x minus y is equals to 18. Now, there were a few issues with this question. The first issue, and what the issues being the reasons why you can't solve it in a way, in a manner you normally do with your questions pertaining to the linear combination of जो भी जो linear combination of variables. I believe that was what the topic was called. Here, the reason here is that while you technically can calculate combined variance and combined mean of x and y, even if they are two different distributions, you can't use those that mean or that variance in a calculation, because if you do combine and find the combined mean for a binomial distribution and a Poisson distribution, शायद आपने linear combination of variables के rules से combined mean and variance तो निकाल लिया, but what do you do with that? Which distribution do you then use? Do you use the binomial one? Do you use the Poisson one? Do you use whatever? So because of that, you simply can't say, you can't simply say कि यार 2x minus y को हम एक और distribution कर लेते हैं, that is z, and then you just go on and solve using that new distribution, because you won't know कौन सी distribution is that new distribution. Because of that, you have to, well, you have to use an alternative approach. And one approach could be to figure out which values of x and y give you 18. And those values could be x is 10, excuse my handwriting. Okay, so x is 10 and y is 2, that would give you 18. If x is, let's say, 9 and y is 0, that would also give you 18. I mean, that would fulfill this particular expression and give you 18. Now, some of you might be thinking that no, it's just one equation, so you would have infinite combinations of x and y that would give you 18. For example, if x was 100 and y was, let's say, 182, that should give you 18, right? But you won't take this into account, because looky here, like the number of the sample size of your binomial distribution is 10. So x can't be any value above 10. Yes, in Poisson, your x values could go all the way up to infinity, but for binomial you have a fixed upper and lower limit. X can only vary from 0 to 10. So using a bit of trial and error, you would get these two values, and it's not very difficult. Like, even if you aren't very good at math, you can just simply try to figure out, put x is 0, 1, 2 all the way to 10, and find and try to see whether you can get a appropriate y value. To do so, again, your y value can't go in negative integers, so you would be left only with these two combinations. Now, what you're basically saying here is you're saying now you have to figure out the probability using the binomial distribution for x and the Poisson distribution for y. The probability that x is 10, you're going to find that out, and y is 2. Probability that x is 9 and y is 0, and you use their respective distributions. Right, and since you're using and, what you'd basically be doing, you'd be multiplying here. So you find the probability that x is 9, for example, and you multiply it with the probability that y is equals to 0. And the reasons why you'll have to find it separately is because you're using different distributions for x and y. Once you have figured out, hence, the probability of the two separate combinations, you add them. Why do you add them? Because you're basically saying that it could be this combination or this combination. Whenever you use or, you're going to add. Normally it's kind of obvious when you should multiply or you should add, but if you find that a little confusing, just remember, and if you're using the keyword and, you should be multiplying. If you're using the keyword or, you should be adding. So I've already written it out here. So this is your first combination where x is 10 and sorry, here would be y, and y is 2. So to figure out x is 10, you use the binomial distribution that was given to you over here. This should be equals to 1. This should also be equals to 1. And you multiply it uh, with the probability that y should be equals to 2, and hence you use your Poisson distribution to find out the probability that y is equals to 2. Just put it into the Poisson formula given, or is also given in your MF9 table. So it will basically give you this into e power minus 3 into 3 square upon 2, which we can simplify to approximately 0.0241. So this is a probability that of this particular combination of combination 1. Combination 2 was where x is 9 and y is 0. So where y is 0, understand 3 raised to the power 0 is 1, and 0 factorial is also 1. So this can simply be crossed out as 1, which gives you e power minus 3 into 10c9 is 10, right? And you pop this into your calculator to get 0.0134. And these are your respective probabilities for the two combinations. And you're saying you either want combination 1 or combination 2, whichever one works. When you're using or, you add which should give you, that's 3, that's 7, and that's 5. Okay. And that's that. That would be your final answer.